uh, type module. Yes. Yes. Once you type module list, it is don't click, then other put can we start?
So I think all of you guys have this RTL-to-GDS folder. Yes or no? Okay, so online people I think is going to be set. So just follow. Okay, so that I will also come to know that okay, all of you are able to follow this. Just do the PWD. It's basically the present working directory. Obviously, it's going to give you the different one, but it's going to be somewhere like home, local, user, L user. Am I right? Yes or no? Okay, great. Now just do the ls, enter. Then you will able to see a folder RTL-to-GDS2. Are you able to see? Okay, so I need a response from everyone. Yes or no? Okay, great. So now just quick check. Just do the which which space VCS enter. Are you able to see this kind of a path? Yes or no? Can you just type it which space Verdi and enter? VRDI Verdi. Can you see this path? Okay, so if anyone is no, then let me know. Okay, it's yes from everywhere. Okay. Then similarly, we'll do DC underscore SHELL and enter. Ah, it's a case sensitive. If you will type anything else without space, or it's not going to work. That's the reason I'm saying which space DC underscore shell. Till that time, I will not ask you to type anything in a capital letter. Don't do it. Okay. Okay. Next is which space ICC2 underscore shell. Are you able to see this path? This or similar kind of path? I think it's going to be the same path. Yes or no? Great. Then which space PT underscore shell? Guys, yes or no? Okay. Now let's do a quick part. Okay. Let's just check whether everything is working fine or not. Just do mkdir, or maybe what you can do. Okay. Just do cd space, now capital, because your directory is in a capital letter, RTL to GDS. Now what you can do, you can just write R and press the tab button. It will automatically come the RTL to GDS. So what you have to do, you have to just write cd space RT capital both and press the tab button. It will automatically give you the whole RTL to GDS and press the enter. Okay. Now if you will do the PWD, then you will see the path as a home local L user RTL to GDS. Yes or no? Anyone outside from this particular path? Okay. Now do one thing quickly. Do the mkdir space test, small letter. mkdir space test and enter. PWD. Okay. Then cd space test, enter. Now if you will do the PWD, you will see home local L user RTL to GDS and then test. Yes. Everything supposed to be in a small letter. Till that time, I'm not going to tell you like, okay, do in a caps. Okay.
All the commands so far has been typing cd.
Everything is in a small letter. Okay. So now let's try whether you are able to invoke the tool or not. Okay. We'll do in the reverse direction. At this, so you're supposed to be in this test directory. Okay. Folder. Now do the pt underscore shell. Type this in a small letter, pt underscore shell, and enter. And then you have to wait for some time. pt underscore shell and enter. Wait for some time, it will take, and it will give you some terminal. I will show you that one. Even it is taking time for me. That's good. Turns out. The other room is allowing. Tell it. Tell it, Mr. Let's see how much time it will take. Is it taking time for you also? Okay. Supposed to be fast. How many of you are getting this PT underscore share? If you see this screen, this. How many of you are able to see this? No. It is same page. Okay, then again, just do the same thing once again. PT underscore share once again. I think it's great for. That I picked that. Internet off over then. We all of you can just try this. We can just go to the application. So here, the partner one is the application. Just open the Firefox. No, no, don't please. Okay. No Firefox. Problem Firefox. Oh, so you can open just do things google.com. So it's not 100%. Okay. Then Bing space google.com and enter. Let's see what is coming. Okay. Those who are getting the PT share, just let me know how many of you are able to get the PT share. PT in the school share. No one? Yeah, let's check.
Yeah. Saying what? Right. Most of them is everyone having everyone getting.com and communicating. So, so why make server, but it just everybody right on the right gap back on on tell me make server. So but you cannot add it. Just do a tag and you should more traffic. Just type that type it to see client has these criteria. If you don't see it, nobody sees it coming up. Just Twitter and leave it on. And then, you have to just type get /investor control. Right. Have it because I added yours. Nobody has it. You didn't add it. Okay, so we have to do it one by one. So what yeah. एक file में लिखा है post करवा दो काम. No, this cannot be. Has to be on the server. Okay. Yeah. Yes. No, it won't take too long. This one has quite then again I want to ask them. So what you can do is log in and okay, so for that you have to just focus on the screen. Okay, that one we are not supposed to do anything right now there. We'll get that. So how many of you have attended yesterday last session by Atul? That's all, 3-4 people. Okay. So there is a something known as the PDK. Just try to there is a lot of content is there. So we don't need that much of content for our this design. So what I'm going to show you the further directory structure, and in that particular directory structure, how the different files are arranged, and then when we are going to run, what is the content of that? We'll do that for the part. In the meantime, everything is going to be good. So in the directory structure, it is the constraint. Now let's see what is inside the constraint. The inside the constraint, it's a full underscore added dot. I just opened this existing file. Now let's first try to understand the different kind of files. Okay, what are the different kind of files? So there are basically 3 kinds of files. Is it okay? All the people, is it clear? Can you see? Okay. So I was talking about the different kind of input files. So now you know the flow. Obviously, you're going to work on the tool. I told you that in the tool, you have to give a couple of files. Now let's try to understand what are the different kind of files. So there are 3 kind of a file. One is the file which is specific to the technology node. That means all the technology information that has no relationship with the design. That is a technology specific file. That means you will get those files either from the foundry or from the EDA vendor. So that means if we are talking about the cadence, then you will get from the cadence. If you are using the cadence tool, you can get from the cadence or from the synopsis or maybe for the Siemens. It depends like, okay, which tool you are going to use it. So those files is going to be read by the tool, and that's the reason I'm saying there is a possibility like those files you can get from the foundry also, from the EDA vendors also. But EDA vendors are going to provide you those files if they have a relationship with that particular foundry. Is it clear? There are the second type of a file which is specific to the EDA vendors. That means those files is related to the EDA vendor. It has no relationship with anything else. Like it's not related to the design, it's not related to the technology, but it's related to the tool. So tool is specific information. That is the second type of a file. The third type of file is design is specific. Design is specific in the sense, best example is the RTL. RTL is your design, am I right? If you are working on a design, that is a design specific. If you will say adder, subtractor, processor, controller, that is the design specific. And that design is specific, obviously on that particular design specific, no one else has a control. Is this portion clear? Now let's talk about the files. I will show you the different files. But now let's talk about how we're going to write the file. What is the format of the file? Now the format of the file is, maybe you will say, okay, I will write in Hindi,
English, maybe some other language, German. It's not going to work in that particular way. So there's going to be a format, there's going to be a template of that particular file, because tool is going to understand you have to write those files which tool can understand. So there are two ways, or you can say there are the two format, or there are the two decision makers. They are going to tell you like, okay, this is the template. One is a standard one, which we will say IEEE standard. So that means there is IEEE standard. Any tool, whether Synopsys, Cadence, Siemens, everyone has to follow that IEEE standard. So one of the file which I have just mentioned in front of you, this is a constraint file, but all the syntax, whatever is written here, that is the IEEE standard. Even though it is a design specific file, because the constraint is specific to these kind of a constraint specific to the design. So that means these are the design specific files, but you have written as a IEEE standard. Make sense? The second is, because who is going to read the files? Tools are going to read the file. That means EDA vendors will come and they will say, okay, this is my standard. Now you have to write the file in this particular way. So if we will talk about any EDA vendor Synopsys, I will show you a couple of files. Those files are specific to that particular EDA template basically. Okay. Now question is, who is going to write? I already told you. Foundry is going to provide you. If Foundry is supporting the Synopsys, and if they have to provide a information so that you can use in the Synopsys tool, so they will write the file which is compatible for the Synopsys tool, or they will write a file as a IEEE standard. And then Synopsys supposed to support that IEEE standard. Clear? So technology file is basically information is coming from Foundry, but it depends like, okay, which tool you are going to use. Based on that, the template is going to be from the EDA vendors. Second is in terms of the design. Now, apart from the RTL, most of the things designer write using the tool. They can even RTL, you can just write on a text.txt or something. You can just write yourself. Then you have to follow a standard. That's the reason whatever the Verilog we are talking about, there's a standard in nature, IEEE standard. Everyone is going to follow that particular part. After that, whatever you are going to write, for example, sometimes we write the constraint file also. That is also like IEEE standard. If anything else as a design specific you are going to write, so you are going to write either as a IEEE standard or as a tool standard. So I will show you one or two files which is a tool specific. EDA. Now EDA is going to give you the certain information. Now they have a flexibility, like, because their tool is going to read the data, so they can write anything in any format, any template, whatever the tool can understand. But the information in that particular file supposed to be specific to the design, not the design, as a recommendation, I would say, or maybe as a technology part. So let's try to understand those files. So this is one of the file which is a constraint file. So which anyways is present in your case as a constraint folder. So there is a constraint folder. Inside that there is a full underscore adder and .sdc. So maybe no need to open this file right now. I'm just showing you here. So there are the constraints are written here. Those constraints are related to the timing constraint I was talking about. So this is a IEEE standard one. Now, then you can see in your area there is a ref directory. So let me just show you the ref also. So there is a lib and there is a technology. Now let's talk about the technology. If I will say tech, okay, let me just do in the different way. So, okay. Now if you will see, I'm in a some folder. Forget about what is this folder, what is the meaning of this particular folder. But inside this, there are a couple of files. Now, if you will see here, it is written CMX TLU plus TF ITF TLU plus dot map and CMIN TLU plus. I will just open all the files and I will tell you like, okay, from where what information is coming. Because if you are running a tool and if you don't have any idea about the file, then it's going to be a problem for you. Okay. So can you see everything is a readable format? Yes. But actually, if you will see the first here, okay, this is something as a hash. It's basically the commented one. It's just for the reference purpose, like, okay, what is this particular file? What is the content of this particular file? But if you will go below, then you will see it is everything is in a binary format. Let me just show you that. Yeah, so see, everything is in a binary format. You cannot understand this particular part. But before this, whatever is the commented one, you can understand like, okay, what is written in this particular file. Now, what information is present in this particular file? Okay. First of all, this is a file which is a TLU plus file. This is a synopsis specific file. That means whatever the content is present in this, that the template I would say that is written for the synopsis tool only. If you will take this file, use it in a cadence tool, it will not work. That is the first thing. But the content is written, it's a technology file. It's a TLU plus file, which is a technology file. That means it should have a information related to the technology. Now, what technology? If you will see, something is written as a conductor, M5. So we were talking about the M1. You remember? I was talking about the metal, like how when you are going to make the connection, it is not a metal one. So how the metals comes to the picture? Level 1, metal 1. If you go to the second level, metal 2, third level, metal 3, is kind of a floor system. Like in our building, we have the first floor, second floor, third floor. That means all the flats on the first floor, we say first floor flats. Am I right? Similarly, all the metal wires on the first level, that is the metal 1. All the metal wires on the second floor is the metal 2. Third, fourth, fifth, metal 5. Now this is that particular metal 5. Here you will say metal 6. Now what is important in the metal? Let's try to understand that. Width. Am I right? Now that is something Foundry is going to provide you. Like, okay, see, if you want me to design a wire minimum less than this particular width, I cannot design it. That's basically, see, here we are talking about the electronics. In a fab, everything is a mechanical and the chemical. They don't have anything with respect to the electronics. Everything is a mechanical and the chemical. So mechanical, that means they have the machines. If they have the machines, everything is basically has a certain precision. Okay, I cannot draw a dimension less than this. That's where these thing come into the picture. Like, okay, what is the minimum width? Now, if you will see here, it is written W min. That means this is the minimum width of this particular wire. Minimum width of this particular wire. Minimum width for this particular wire. Similarly, S min. That means if there are two wires, what is the minimum spacing between those two wires? We discussed that particular part. And these are converted into the design rules. Basically, when you will do the physical design, after that in the physical verification stage, there is a different tool. They are going to verify whether you have drawn the structure with respect to this particular dimension or not. Whether your dimension is greater than this or the less than this. If it is a less than this, they will say, okay, there is a violation. There is a problem. You have to fix it. If it is greater than this, there is no problem. That means this is the technology part. Now, when we were talking about the routing, so we are not doing the routing by hand. We are telling the tool, like, okay, see, you have to draw this particular layer. Am I right? So you have to tell the tool like, okay, what is going to be the minimum weight, what is going to be the minimum spacing, how you're going to tell the tool using this kind of a file where it is mentioned as a W min and S min. Clear? Eh? So this information, there are the couple of other files also. So there are different tools in a synopsis. They have the design compiler, they have the ICC compiler, there are different stages also. So the history of the synopsis is, it's not like there is a single person, they write the code, they write the whole tool chain. It's like the multiple people, they started writing at the same time, at the different time. So they started with their own template file. Now what is happening, like as a user, now we have to provide the same information in a multiple files. So I will show you the multiple files also, but this is a one of the thing. Then if you remember the, what is the, anyone can just tell me what is the formula of resistance? Rho L by A. Okay. Now what is the rho? Resistivity. Now if tomorrow with the help of the tool you have to find out the resistance of a metal, then you have to tell like, okay, what is the resistivity of my metal? So foundry is saying I am going to fabricate, so I am telling you the resistivity of the metal. So this is the resistivity parameter. Now when we are going to calculate the capacitance, then maybe you need the actual wire. Okay, width is this, length is then, what is the thickness? Then only you can figure out the actual wire. Wire cannot have like length and the width. Okay, it will also have the thickness. Now from where that thickness will come into the picture, that is also supposed to be part of a some particular file. So if you will see, it is NES, am I right? N2S, okay. Yeah. So now this thickness portion is there. Thickness, width, min. So here as a sample, it has only 4-5 parameters, but in the actual file, you will see there are almost like 10-20 parameters are there. Now, I will just tell you about this particular parameter also, dielectric. So if there is a wire, okay, then there is another wire, and if I will say like, okay, you have to place these two wires, are you going to place it in the air? If you will place it in the air, they will be like fall down. Then you have to place something in between. That something is basically should not be conducting, because if it is a conducting, it will conduct. So you need something as a non-conducting. That non-conducting is a dielectric. It has a dielectric constant, like we always study in physics, dielectric constant. So that is basically the dielectric. What is going to be the thickness of the dielectric? What is that epsilon? Dielectric constant. So that dielectric constant is also there. So now there is a wire, there is another wire. If I will ask you, okay, find out the capacitance between these two wires, you can figure it out. The tool can figure it out. Like, okay, this is the wire, this is the wire. What is the distance between these two wires depending upon this particular thickness? What is the rho? C equals to epsilon A by D. A, you can figure it out. What is the overlapping area? D is this particular distance. So that means resistance, capacitance of any particular wire, you can figure out from this particular file. So this is a one of the file which is present there. Now, let me just show you one more file. Yes. Just 1 second. Okay, let me just finish this and then I will take your doubt also. Okay, now try to understand when I was talking about the metal one. I was telling you METAL metal 1. But somewhere maybe someone just mentioned M1. Because I was telling you, like there are the different people, they have written the code in a different time frame. One said like, okay, if it is written M1, I will consider it as a metal one. Someone said if it is written as a METAL in a caps letter, then I will consider that as a metal one. Someone said like, okay, MET 1, that is also a metal one. A small letter metal one, that is also a metal one. And foundry is saying, see, I don't care about this different naming convention and everything. We have a concept of layer number. So when you are going to provide the whatever you have designed to the foundry, you are not going to provide just like that. There is something known as a database you will provide. That database is basically kind of a GDS database. It's saying it's become a standard nowadays. Okay, it's a graphical design, something is there. So that is known as a GDS database. So every foundry, so it's a basically triple E standard, IEEE standard. Every tool has to support that, and every foundry will tell you like, okay, see, I understand the language of these layers. So metal one supposed to be M1. Let us suppose they said in this particular way. There are a few foundries, they are saying, okay, I can understand metal one, metal two, not as a M1 and M2. I understand this thing as a CA, CB. So like Global Foundry, they don't have the concept of M1, M2, M3, M4. They have the concept of CA, CB, BA, BB, TA, TB. So they have the layers they define in this particular way. So the ground level, maybe they will say it's a CA, then the next is the CB. There is a TA and the TB. They will come up with this particular point. Now, if you will go with this metal 1, metal 2, metal 3, and you will write out a GDS based on this, and if you will give that database to the foundry, they will not be able to recognize this because it's not as per their requirement, and they will not be able to fabricate anything. So then the concept of the map file come into the picture. Map file in the sense any two tools or a particular tool versus the GDS. So you have to write that particular part. So like here, if you will see, PO supposed to be mapped with the poly. Similarly here, metal one, till this there is no problem. CO supposed to be, it's like a poly contact. So this map file is there. Now this map file, sometime it is not required, sometime it's required depending upon what exactly we are doing. If we are in the same environment, like for example the synopsis environment, one stage to another stage, if we are just giving the data, maybe that is not required. Whenever you are going to shift the tool, you need them. Who's going to decide the template of this? Synopsis is going to decide the template of this particular part. Yes? Okay. Now this is the second type of a file. Yeah, so someone has a question. Yes, please. Maybe you know, I don't know. So, joke apart. Okay, so what he was talking about, because he has an experience, he has done work. That's the reason he asked this kind of a question. Now the question is, let me just put the question.
So what we'll do is, we should have taken.
Oh, it's 140. Okay.
Yeah, 140. We'll take a lunch break. You take the faculty to the canteen. You are from outside here, but you not to take care of it. And by the time you come in,
So I need 5 minutes before I just wrap up this part. Okay.
yeah.
So the question is like he has a understanding as we go from metal 1 to metal 4, 5 resistivity to change. That is his understanding. So it's not a universal rule like, okay, metal 1, metal 2, metal 3, they will have a different resistivity. That's not like that. There is a concept of metal stack. Maybe we will not go till that particular place, but What is that? It's like you have an option. You can decide, you can choose whether you need the metals for the different resistivity or the same resistivity. So Foundry is going to provide you, Foundry is going to tell you like, okay, see, I can give you the options. Metal 1 to metal 4, this kind of resistivity, metal 5 and the metal 6 with a different kind of resistivity. You can choose any of this particular metal stack. Metal stack in the sense, 5 metal, they are placing one above the other. Okay, so the answer of your question is, it's not a universal rule like, okay, if you will go the top layer, or you can say if you will go the next layer, the resistivity is going to be different. So the layer, the map file which I, not the map file, the TF file which I showed you, in that the stack was like 6, 7, 8, it has the same resistivity. Maybe the top layer, maybe the resistivity is going to be different. You can just check that particular part once everything is up there. Okay, now before we go for the lunch, I just want to show you that important one, which is a standard cell library. So how the standard cell library is there. So if you will see, there is a one folder, standard cell underscore RVT. Now here there are a couple of files. You can also check in your area. There is a some file as a extension as a .db. Some file is a extension as a .lib. So .lib is a, both the file is basically the IEEE standard, first of all. Okay, not the both the files, sorry. The .lib file is a IEEE standard. So that means whatever the syntax and everything is written there, that is as per the IEEE standard. But .db is a specific to Synopsys. So what will happen? What Synopsys has a different tool. Using that particular tool, they are going to convert this .lib into the .db. Even though it has the information about the same information, but it has a different format, which is a binary format, which their tool can understand easily compared to the .lib one. And this .lib has a information about all the cells. So I will just show you one of the cell here, so that you can understand. See, it is a readable file. You can read this particular file. Whenever you will get a time, you can just read it. I'm just searching for and if you will see, there is a and is written here. That means the someone who designed this particular AND gate, they captured the property of that particular AND gate. They captured in this particular file. The one parameter which we have discussed is the area. If you will see the second one, area is mentioned here. That means they designed it, they did the certain simulation and everything, and they captured that area. They just mention it here. That means when the tool is going to read the information, tool is not going to calculate the area. Tool will just read this particular file, see this particular name, and figure out what is the area. Now, when I was talking about the mapping, you remember I was talking about the mapping. There is a AND gate in your circuit. If you will say, okay, what kind of a AND gate? It will say, okay, there is a library. This is that particular library. In that library, there is a AND gate. This is that particular AND gate. So if you will see is AND 2x1 RVT. If I will go down, there is another AND gate, AND 2x2. The difference is x1 and x2. What is the difference? Maybe sometime later we can discuss this particular part. But that means the same file, there are the two AND gates. Now those two AND gate are of a different type, different property, different delays, different power, different area. Now based on the constraint which we have seen in the constraint as a part of a specification, when the tool is going to map it, tool is going to map it with respect to this or the previous one, or if there is any other AND cell. So there is a linking of the libraries with respect to the circuit. So when we are going to run the scripts, then I will show you like, okay, there is a certain set of a library which you have to tell the tool like, okay, these are my libraries. Now You will not go in an internet and just search all kind of a library. It's not like in a driver. Okay, search it. Okay, I'm just providing you a path. In that, you just search it. So that target library, that syntax is there. You will just provide those kind of a library, and then you're going to link it. So at each and every stage in the physical design, there is a something linking. You will see that particular message. If linking is going to fail, you will not be able to do anything. So you have to link it. The message will be there like, okay, I'm linking the design with this particular library. And if the linking is successful, then you can do rest of the part. Done? So RTL, I think I'm not going to discuss that thing, but that is very important. Then the second thing is a constraint file. That is very important. This library where there is a .lib file, that is very important. And then the technology file for the our different kind of physical portion. Technology file is important. So we'll discuss this particular part. Okay. Now I can go for lunch, and then after lunch we'll do the this part. Okay. So let's quickly do this PT underscore shell and just enter. Okay. Let's see how much time it will take this time. Yeah. So in my case, it's coming. What about rest of the people? Yes or no? This side last. What is happening? Okay. So maybe if you can shift to this machine, try this. Ah. Similarly, just do the ICC2 underscore shell. Enter. Sorry. You have to write exit, EXIT exit, and then enter. Okay. So it will come out. It will be a part of normal test, and there you can just write ICC2 underscore shell. It's done. Okay, so go to the test directory. Okay, so you are inside the test directory. There, first try PT underscore shell. You got the PT shell. Then type exit, EXIT exit, enter. Now you're coming out from the PT shell. Then after that, you have to do this ICC2 underscore shell. It may take some time depending upon. Okay, so now I think something is happening. So you'll get a terminal like this. Okay. Yes. Yeah. So in my case, it is there ICC2 underscore shell. Okay. Then again, you have to just do the EXIT exit. Now let's do the DC also. Once you will get the prompt. DC underscore shell. Enter. So next time when I'm going to tell you like, okay, shell, DC shell, PT shell. So these are the commands which you have to type. Okay, DC underscore shell, PT underscore shell. It's taking time. Not a problem. It will come. So, by the way, whatever we have discussed till now, any one of you have any question? I obviously like not as a tool point of view, but as a concept point of view, anyone have any question? Yes. You can just note down. That is a disadvantage of thing there. Okay, okay. So now you have this DC underscore shell, okay? So that means in my case also all the three tools are working, and then you can just press exit. Now we tried like, okay, yes, all the three tools are working. BCS and YD we will just work right now, so we will figure it out, okay, whether it is working or not. So now what you have to do, you just say write, because you are in a test directory. So now just let's come out from the test, cd space dot dot slash and enter. Then you will do the pwd. Now you are outside that test directory, cd space dot dot slash. So that means now you are outside one directory up, okay. Then if you will do the pwd, you can see the path. It's supposed to be the RTL to GDS. After that, if you will do the ls list directory, so it will show you this particular part. Now let's go with the one by one. Let's go in the RTL, cd space RTL, enter and do the ls. Then you will see one file there. So this is a Verilog code which we have already written for you, so that you can directly work on this particular part. So what you have to, what I'm just trying to show you, the code. So if you will see this particular part, how many of you are able to see it? No. Okay. That's the reason labs are there. So you can do one thing, just say cat, okay, and then space, then full underscore adder underscore RTL.v and press enter. So if you are inside the RTL folder, what you have to do, just say cat space RTL and press the tab button. It will give you the whole path. Full underscore adder underscore RTL, okay. So what you can do is just write full and tab button. It will automatically give you the full name, okay, and then enter. Now if you see here, so there is a module definition. You can see in your screen also. Here I have mentioned full underscore adder as the module name, and then there are a couple of path names are there, A, B, C. Okay, these are basically the input output ports. Okay, so you can just check it there, na. She also have the same thing. Okay, then this file you can open on your terminal also. That has no relationship with the tool. Okay, are you getting my point? So tool is like when we are going to run the VCS or something, then maybe you are facing a problem. This is the file part. Yes. cat space. Okay. So do one. Just do the pwd and just tell me what is the path. Path is coming. Is it like RTL to GDS? Yes. Then do the cd space RTL, enter. cd space RTL, enter. That means now you're in an RTL directory. Now do the cat space. Okay. Okay. So I was just sharing this particular part. So these are the ports: input port, if you will see, it's written 3 is to 0, 3 down to 0. That means there are the 4 pins 0, 1, 2, 3. Okay, so it's a 4-bit input A and the input B. Similarly, clock C in, these are the two another pin. One is the clock pin, naming is the clock. Okay, that doesn't mean the tool will automatically understand like, okay, it's a clock. You just named it as a clock. Okay, here's a C in. It's for your understanding, like, okay, you're giving this particular name. Then we are talking about the output as a part of a register as a 3 down to 1, the name of that as a sum, then another register as a C underscore out. So in a full adder, what happened? There are the input pins A and the B, 4 input for A, 4 input for B. Then we have another pin as a C in, that is also the input. And then we have a clock pin, which is another input pin. Then we have the output and C carry. Now you may ask like, okay, Puneet, what is clock? Because in case of a adder, it is a pure combinational circuit. Now how come clock come into the picture? So the way we design this particular adder, you have to understand that camera, na? Is it working? Okay, let's see if they will complain then. So basically it is kind of a adder like this. Okay, S0 to S3, A0 to A3, B0 to B3, then we have C in, then we have the clock, and then output as a C out. Now question is, what is the circuit inside this? I will show you that particular circuit later on, but since I am writing, I should have a good understanding about the RTL. Now what I have done, for example, inside this there is a adder. This is my adder, 4-bit full adder, which is a pure combinational circuit. But in industry, let us suppose if this is your adder, and in this particular adder there is a pin A not and the A1. And manually, if I will ask you, like, okay, now you have to apply signal. Can you apply the signal at the both the pin at the same time? There should not be any difference. There should not be any delay. I would say the delta of any nanosecond. It should be precisely at the same time you have to apply. Whatever your speed, you cannot apply. Am I right? First, you will apply either on A0 or then you will apply on A1. But if I will see in that particular way, let us suppose your data is 0001, that is your A0 to A3 or A3 to A0, and the another one is a 0010. So this is A and the B. You are doing any kind of a addition, so you know that okay, addition will be 1011. Yes. Now what you have to do the next addition? What you have to do? You want to do 0001, 0001. Okay. So this change we are talking about. Initially, the first number was 0001, 0010. Now I want to change the B, and that change in the B is from 00102 to 0001. And that means at the same time, 2 bits are changing. Am I right? Now the question is, how you are going to change? Are you going to change the 1? Which one you are going to change first? Are you going to change this 1 to 0 or 0 to 1? Because if you are going to change one by one, your output will be with respect to that. So if I will say, okay, I will change first 1 to 0. So first output as is this. Then the second time when you are going to make a changes at a 0 to 1, then it will be like this. Correct answer. So that means think from the second side, okay, receiver side. They will get the two output. Now how they will come to know which one is the correct one? Because you're making a changes and you will say, oh wait. When I will tell you, then you have to check that particular output. Till the time I'm doing certain experiment or I'm just changing the input, it's not a stable output. That is the word you can use it. Or what you can do, you can say like, okay, let me do one thing. In the input side, I will have the registers. All flip-flops are there. First, I store the data in the flip-flop as a parallel, okay? And then with the help of the clock, I will trigger at the same time. I will trigger all the flip-flops at the same time. The moment you are going to trigger, all the flip-flops will give the data to the next stage. Make sense? Now, storing depends on you. You want to store it at the same time, you want to store it at a different time, that depends on you. I did it, but looks like maybe camera is not on here. Yeah, camera. So what is that camera? Okay, this is a office something. Am I right? Yeah. So that is on. I think now they can see. Yes. I can see, but not like that. Maybe we can put it here. Ah. Yes. I think now you are able to understand the significance of these flip-flops. So what we are doing as a part of a, if I have to design a adder only for the industry purpose, not for the college book purpose. So at least your expectation is like, okay, all the inputs supposed to be given to the adder at the same time. So that's where the clock come into the picture. That means there are going to be the 4 flip-flop for pin for data A, for 4 flip-flop for data B. There is going to be one clock that is going to connect with that. Whenever there is a positive clock edge, data will be like from those flip-flop to the combinational circuit. Now same thing you can do in the outer side also. You can also say like, okay, on outer side also I will have the 4 flip-flops and that clock will be here only. And the output, it will come at any point of a time. Make sense, guys? So that's the reason the clock is a part of this particular program. Now, if you will see here, in a Verilog, there is a, if you need a sequential part and you want to trigger it at a particular edge, so there is a always pause edge. You can just check the syntax. So that syntax is there, pause edge clock. And then we are saying, okay, the pause edge, what will happen? A is supposed to be the part of a register 1, B is supposed to be part of register 2, C is supposed to be part of C in, that is also a register, okay? Then pause edge, we are saying sum I, whatever be the output of actual combinational adder, that is in a small I, that's supposed to be part of capital sum, which is a register part. C out supposed to be part of C out. And what operation you are doing, that we have specified as a part of a always. And then these are the two inputs, like these are the two outputs supposed to be reg1 plus reg2 plus C in. So if you will see, there is an equation only. We are not specifying any circuit or something. I just specify in this particular way what is the behavior of this particular circuit, and done, and module. It's a very simple code. So what you can do later on, maybe after today, you can go back and you can just similarly, you can just try for the subtractor, maybe the bigger adder. In place of a 4-bit, you can go with the 8-bit adder also. whatever the way you can write a RTL, you can just write a combinational RTL. In the input and output, just apply the flip-flops. It become a industry specific that design. Okay. Now let's do the simulation, translation, whatever to do it. So okay. So for that, what you have to do, just do the CD space dot dot. Let's come out from this. Then there is a RTL underscore simulation directory. You have to write CD space RTL underscore simulation and enter. Do the ls. You have to do this particular part. So when you are going to do the PWD, you will be like a /home /local /l user RTL-to-GDS RTL simulation. Now for your understanding, I have done like I just tried couple of things so that it's become easy for you. So what you can do, you can just open one more terminal. I think all of you can open one more terminal. Keep this terminal as it is, just open one more terminal. And you can just go to the same directory as a cd slash, okay, sorry, cd RTL to GDS, RTL, enter cd RTL simulation, enter. So I'm inside the same directory. So maybe you will not be able to see this particular part, but this is the same directory. And I will just, the reason I just done the part because I want you to open in the second terminal one important file. So can you see this particular file, which is like VCS underscore command in your folder? Can you see this file, VCS underscore folder? So in the new terminal, what you have to do, just do the cat space VCS underscore command and enter. So if you will do something like this, so you will see these four lines. VCS minus full 64 full adder dot V. This is the same full adder dot V. Then something like minus debug underscore access plus all minus LCA minus KDB. So that is the first command. Second is, yeah, so basically first one is the commented one. Second one is with respect to the TB. Okay, that is a test bench. I will show you what is a test bench. Then there is a simv wordy, and the third one is a wordy. There is some command is there. Are you able to follow this? cat space VCS underscore command. So you have to go first in a RTL underscore simulation. Inside that, just do the cat. I just want to show you these three commands. So cat is basically going to display. Cat is going to display the content of the file. So I just showed you like the content. Yes, done. So all of you guys are under RTL underscore simulation. Yes or no? Yes or no? File or directory not found. Okay. So you are, if you will do the PWD, you are inside the RTL folder. Am I right? So first you have to come out from the RTL folder. I told you like, okay, you have to do cd space dot dot, then you will come out the RTL folder. If you will do the PWD, then you will see RTL to GDS folder. Okay, the last one. Now you have to go into the RTL underscore simulation. That is cd space RTL underscore simulation. Now inside that. Am I right? Can you do the cat space VCS underscore command now? Now from here, I will run the VCS tool. From the same directory, I will run the VCS tool. So there are two options. Either I will go with the one by one, or I can source a particular file. But just to show you, let's do one thing. The first command, this particular command, okay? If you can type this particular command, it's very good. Just type it in that particular folder as a VCS. Same. You have the reference, like command is there, you have to just do the copy paste. Don't miss anything, okay? Minus full 64 full adder dot v. Okay, so I think full adder. Go with the full adder tb.v, okay? Second command. And then minus and then you can just press the enter. So whatever be the second command, na, uncommented one, you have to type that. You can see this particular part, okay? That is the commented one. Yeah, just leave it. Let's go to the second one. Basically, that file is not there. So you can do it, but rest of the people, they will face the problem. So let's do the, sorry. Then enter. Enter after this, just enter. I told you, like, okay, in place of this full header, go to the second command. The cat, na, there is a second command. Dot .tv, yes. Have you done it? It is saying does not exist. Full header dot .tv dot .v. Oh, can you just do the ls? It's a underscore TV, okay? So your file name is wrong. Okay, so what is the warning? Unknown option passed. What is that unknown option you have passed? Tell me. KDB or KBD? Working? Then no. So yours is so after that you have to type this command, na, second command. You have to just type and press the enter. What is that error? Incorrect tool setting. Okay, I'm coming. Let me see. It's working. Show me the incorrect tool setting. Just scroll down. Debug access plus solve, pass to the VCS and continuing logic compilation. Try once again. Okay, I got it. Enter. Let's see. Same one. Now yours is done. So there is no problem with your side. Now you can do that this particular part. I'm coming to okay. So no. So you have to come out from PT shell. Do the EXIT exit and enter. Just do the PWD here. Coming, just wait, let it come. हाँ ठीक है, होने दो उसको. Let it be. It will be done. So in your case, yes, it's successful. Good. Okay. ठीक है, I will check. Okay. In your case also the same thing. No, so in your case it is not able to get the license. So were you able to get the PT underscore shell? Okay. Let me see. That it looks to me same. No, no, your case is a different. Yours is a different one. Can you just try same thing once again? In your case, you are failed to obtain the license. मैं वही देख रहा हूँ कि PT shell. PT shell she was getting. Working. Can you just do the LS here? Okay, I think you can just check this particular part. I just want to show you a couple of things. If it has a problem, it's working. Database successfully. What is the issue there? Okay, the GCC part. No, everyone. I think 4-5 people they're getting that portion. Yours is fine. Okay, so not a problem. I think those who are facing that GCC problem is okay. You can just check the nearby laptop or the desktop. Okay. So what you can do after this? What was our second command? It was a sim command. Am I right? That was a /simv. So you have to do the same thing. Simv space wordy and enter. It is /simv. It is the second command in the VCS underscore command. Third line basically. First is commented. Second one with respect to which you guys have tried. That few of you are facing license issue. I think ignore for the time being. Someone is facing GCC issue. Ignore for the time being. The third one, they are like able to compile it properly. It is saying successfully generated. For them, the next line is a /simv and space wordy. Try that particular part. It will show you the certain numbers like A, B, C. If you will see in front of your screen, like if you will see here, it is saying this particular part. Now what is happening? It is written as a part of a test bench. Now what is a test bench? Those who don't have the idea. So if you write a circuit, if you design a circuit, if I will ask you like, okay, whether your circuit is working or not, what exactly you are going to do? You will say like, okay, I will apply the input and I will see whether I will get the similar desired output, not the similar, desired output. So there are two ways to do this particular part. One is with respect to the waveform. So I will show you the waveform. But input you have to apply. So this, in the test bench, we write all those inputs. So when we will talk about the VCS, it's going to simulate. Then after that, test bench is like you are writing a test bench through which you are going to test your circuit. In that test bench, you are going to write, or you will just write all the inputs. Now, in case of a 4-bit adder, what other inputs are there? You will just give the, right, like in a truth, okay? In the truth table, you write all the combination of A and the B and the C in, and you will see, okay, whether I will get the proper output or not. So can any one of you just let me know for a 4-bit adder, we discuss just right now, there are the 9 inputs except clock. 8 plus, sorry, 4 plus 4, 8, 1 C in, 9. Then the clock, forget about the clock. There are the 9 inputs. How many combinations will be there? 2 to the power? And if I will ask you like write all the combinations, going to be very difficult for you. So what we have done, we just tried 4 combinations. But this is just for a adder. Tomorrow you will go for the ALU control or something. Then how you are going to do it? That's the reason people came up with another language. Is kind of creating an environment around design. So whatever with the Verilog you have written, around that they will write another code which is going to automatically generate these patterns. These are the patterns, am I right? These are the combinations. This we can say. So if I will say like, okay, I will automate this part also. So it will that pattern, then that give it to your circuit. It will generate certain output, and then it will verify like, okay, what is that particular output, whether it's the correct or wrong. So verification, whether you are doing with the help of the system Verilog, UVM, OVM, whatever you're doing, is kind of creating an environment to validate. Make sense, guys? So I'm not going to teach you the Verilog, system Verilog or the UVM, but I'm just telling you like, okay, this is the way it has been written. Okay. Now, second way is the waveform part. So like here, if you will see here, it is written 0, 0, 0, 0, 0, 0, C in. You can verify, okay, this is the sum. If I will give 1 and the 1, it's supposed to be 1, 0. If it is something like 1, 1, 0, 1, 0, 1, 1, this is the sum, this is the C out. This is what we have done till now. Now, if the same thing, if I want to do on a waveform, so Verdi has a similar capability just to show you the waveform part of that. Now, what you can do, the third command in the VCS underscore, that command, just type that, enter that. How to get this screen? Okay. So in the VCS underscore command, that particular file, there was a third line, /simv space Verdi. You just do the cat and that file name, you just cat it, copy paste you can do it, type it. Okay. Now I'm just also doing this in the same place as a third line as a Verdi space minus SSF novas.fsdb minus no logo and enter. Now maybe you can ask me like, okay, I'm just giving you certain commands. What is the significance of all these options? Okay, and it's going to be very difficult for me to help you with each and every command. But it's going to be very easy for you if I will tell you like, okay, how to study about this particular command. So after this, I will just show you that particular part. So what I have done just till now, that command, I just pressed it. Something just automatically happened. One window has opened. In that particular window, you will see same code has been captured here. Now nothing is here. So this is the waveform part. I will say, okay, how you're going to add the waveforms here. So this is basically the Verdi interface. In this Verdi interface, you have the test bench, you have the code, everything. Now you can play around this particular part. So what I'm going to do, Okay, so I think if you are not able to see, I'm just telling you this is the same code where it is written as a reg A and a B. So what I'm going to do it, I will just select this. Okay, then in this particular window, I will just select add to waveform. I will just do that thing, so you can do that particular part there also. So for example, I just selected this, right click, there is an option as a add to waveform. So there is right click, select this, right click. If you will go a little down here in the highlight below that, there is a add to waveform and the new waveform. I will just click on the new waveform. Now you are not supposed to import. This will automatically come if you have followed all those 3 steps. Have you done the first command, VCS, then the SimV second, the same place if you will run the this, it will automatically load this thing. Okay. Just do the ls here. Maybe what we can do, we can just remove the SimV, just clean SimV directory. You can just create this file, and this CHRC file, and you can also remove this also. Yes. And the wordy config file. Now, it's done. Oh no, same. SimV cannot be opened, or no. Oh, okay. Like what is the command? It's almost the same. Maybe you can do step by step. KDB, enter. There is no problem here. Yes, now we can do that second one. Same wording. Maybe we can just that is not required. No, but I think now source file cannot be opened.
But I just executed the second command after me.
It
Oh, I didn't. Oh, how did that dot thing be? Oh, sorry, my fault.
No.
I think it got included both of them. Yeah, so the dot thing.
Can you just do the sim dot sim? It's a dot dot.
So it's dot dot.
No, there is a single dot.
Yeah.
Okay.
But there is no executable here.
Just do the wording. SimV not generated now. No, permission denied now. So
what to write there? Before that?
no, it's here only. The GCC, no, so in your case, GCC G++ command not found. Yeah, so see, just check here. It's like she's of the same problem here. First one, if you will just run the first one. G++. Okay, yes, that is. Okay, so are you able to get this? No. What is the issue? Incorrect. So you are getting that from the first itself, now. You're not able to run the VCS. Okay, then I'm ignoring you. Clock. So in your case, clock input is not coming. So do the same thing. Select the clock, right click, add to the waveform. It will give you the waveform, like, okay, there are the 2 or 3 waveform. Just select one waveform. It will be there. It depends, like, okay, how many pins you want to, like, what are the inputs you want to be part of that. What about you? There? Clear? Okay. So now I think this particular waveform, now you can do the analysis like, okay, what you are applying as A, B, what you are getting output. There are a lot of options in the wordy where you can provide environment, okay, like system Verilog, if I'm talking about, it do a lot of things. But right now, maybe for this particular workshop, how to open the tool, how to do the three lines are important. Then once you will enter here, you can play around. So there are a lot of videos already present on the YouTube. You can just go and just check, okay, how to run the wordy, what are the different options. So you can do in that particular way. At least you will get certain idea like, okay. Yes, sir. Yes. Okay. So one another thing. So can you see this corner one here? This place, okay? There was something written a test bench, then there is a something as a DUT, okay? If you will do here the right click, there is an option of, okay, maybe not here. About this, there is a schematic, okay, yes. So what you have to do, here wherever it's written DUT, right, just select this. At the above this, there is a some symbol is there, waveform, okay, some clock waveform type, and then there is a something like an AND gate is there. Just click on that AND gate. So it will open a window which is kind of a schematic like this. So here you can see it's written like, okay, there is a full adder, there is an inverter. You are just feeding certain data inside this, okay? So in the left corner, there is a small window. It's written test bench. And under that test bench, there is a something written as a DUT. Okay, design under test. Okay. Now just click here, select this. Then in the above, there is a certain icons are there. One is a waveform icon, another is a AND gate. If you will just hover your mouse, it will tell you like a schematic. Just click that particular symbol. It will open a new window. It is like in a kind of a schematic. Top level. The RTL you have designed with respect to that. So, yes. Yeah. Okay, so now what you have to do, go do this, select this, right click and add to the waveform. Maybe you can say new waveform here. Okay. Now this is something I have done only for the test bench. This is for the test bench. But if you want to do it, you can do it for normal your RTL also. So in the first command in the VCS underscore command, which is a commented one, you can just use that, fix the file name there, try it there also, and then open the wordy. The code will be there in a one window, select, and it will give you this kind of a waveform. Okay. So this is basically the way we do as a VCS simulation. If we have to verify, we do the verification. That's all. If your VC, if there is any problem, now how you will come to the problem? Maybe you'll not get the correct waveform, okay? Or maybe some other syntax error. It will tell you, okay, there is a syntax error. So at that particular time, compilation is not going to happen. Like when we were running the first command, na VCS, it will give you the error, file not found, syntax is incorrect. So you have to fix that particular thing as a part of your RTL. So now let's go to the next stage, which is like how you're going to synthesize it. Close this window, and then we will go to the next stage. I told you, like, leave it. Another? No, that's not. I don't think so. If it will come, we'll see.
Yeah, now I know.
That is like, then why it is like confused there, not there. Oh, centers also.
So not sent all format, but there are some videos which got updated after.
Okay.
This was just not required in
Ah. Okay, guys. So now we are in this directory. RTL underscore simulation. Okay. Now go to the previous directory. What you will do, cd space dot dot enter. Then again you will come at the RTL directory. RTL to GDS, this directory. Okay, you will see all this thing. Now we will go to the next stage, which is like after the compilation, VCS and everything. Now we have to synthesize it. And we are going to do the synthesis using a which tool? Which tool? Sorry? Just 1 second. We will do the mapping. You remember? I told you like that is known as a synthesis, logic synthesize. We will synthesize the logic with respect to the cells. And for that, we will use the design compiler, which is a DC. Okay. So if we have to do in the DC, we will go into the DC folder. So we'll do the DC, CD space DC. Now this DC is a capital letter. Okay. Enter. If you will do the ls, you will find these different files. Okay. Yes. Just do it and just let me know. Then close it and do this. It's done. Okay. No. Open the terminal. No, sorry. This window. Close this window. From me, no, not from me. This. Okay. Yes. This only. Yes. Go to the terminal. It's already there, na? Now go to the DC folder. CD space dot dot, and then do the CD space DC. Now let me show you like, okay, what is the content here. So see, I was telling you a lot of things. There are a lot of commands, you can run it. So there are the command, there is a file which we have created for you people, which is a, let me just show you here. It's a run underscore DC dot tickle. It is a automated, what we have done, run underscore DC dot tickle. We created a file system where the different commands are present. Like here, the first line, if you will see, I'm sourcing another file, which is like inside the rm underscore setup, DC underscore setup dot tickle. So what happened in the industry, like obviously you cannot type each and every command manually. So you have seen this VCS underscore command. I asked you just to type the 3 command. It took a lot of time. Now in this particular file, if I will just scroll it down, you will see these many commands are there. And if I will ask you to type this every time, if you will make a small mistake, type it again. Then either you make certain mistake in terms of the spelling, or maybe you make a certain mistake in terms of the sequence, because sequence is also very, very important. So there is something known as a reference flow. It's like every company nowadays, they are providing a reference flow. When I'm saying every company, it's like every EDA company. All the synopsis, cadence, they will give you a reference flow. Then they will say, okay, this is our reference flow where you have all the different tools you have to run in this particular sequence. But obviously from the design point of view, you have to customize that flow. In the sense, customize in the sense, from the design point of view, what is the RTL, what is the name of the RTL, where the libraries are there, which library we are talking about, which PDK technology file we are talking about. We have to point all those things in a different format. Okay, and then depending upon whether the design is small or the large, you have to configure that particular template. So the file which I have opened in front of you, it is a mini version of that template, and we usually say it's a reference flow. Okay, so this is the EDA company, basically the way they are providing. But similarly, on a design company side also, there are companies in the design side, they are also doing the same thing. They have their own flow. So like NXP, Qualcomm, Intel, they have their own flow based on their requirement. Is it clear? Yes. No need to get this. Okay. I'm just showing you that particular part. Now, let me just show you few more things. So like, if you will see here, let me just explain little bit. This is one of the file. I will show you what is there inside this particular file. There is another one where I'm just setting this particular variable RTL underscore source file. So if you will see, this is the RTL I'm talking about. So my RTL, if you remember, it is inside the RTL folder. There was a file full underscore adder underscore RTL.v. This is the same file. That means I'm telling the tool, as a design compiler tool, I'm telling, okay, this is the RTL on which you have to do the work. So that I have set as a part of this source file. Then there is a path. There is a certain variable where I'm saying this is the working path. You have to just the work, you have to do the temporary work, you can just do here. We'll come to this particular part later on. Let me just scroll down little bit. So if you will see, the next command is RTL source file. Analyze minus format and the verilog and this RTL source file, and this is the same file which you have, this is the same variable which you have defined above. You are telling the tool that, see, this is the verilog file. The format of this file is the verilog. It also supports the VSDL. What you have to do, you have to analyze it. Padh lo isko and just see what is the content inside that. Elaborate, same, whatever be the design name is there. Now from where this design name is coming, I will just show you this design name variable from where it is coming. But whatever the design I'm going to define, just elaborate this particular part and then set that as a current design. After that, compilation, compile come into the picture. So there is the command compile. Yes, it's a very simple. As such, the only three commands: analyze, elaborate, and compile. But in that we set one variable, second variable, one variable in the same file, and the another variable in DC setup. Okay. Yeah, so there is another file, and here we have mentioned this design name as a full underscore adder. It's the same variable. Okay. Then there is a one more. Now this variable you can define in the main file also. That depends on you. But like I said, it is a mini version of the reference flow which industry is going to provide So that's the reason we have done this particular part. But that doesn't mean you have to do this in this particular file. You can do this in the main file also, or you can type this as a terminal also. Another thing is, in a synthesis side, it is very important you just provide where your libraries are present. Only then it is going to map. So in that particular file, there are only 3 commands. But in the synthesis, we discuss very clearly, like, okay, it is going to map with the libraries. Now, where is that library path is defined? So I mentioned, like, okay, there is a ref path, and inside this ref path, there is a certain files are present. Here, if you will see ref path, then there is a library, standard cell RVT, then some name is there, .db file. And I showed you in the morning before lunch, like, okay, there is a ref folder, inside that there is a lib folder, there is another folder, and there is a db path is there. So we are basically telling the tool, like, okay, this file is present at this particular place. Now this variable, again, I'm just telling you again and again, these variables you can define in the main file also, but industry people are like, okay, commands are in a one file, all the variables in a one file, and whatever the relationship between the command and the variable, that's supposed to be in a third file. So that's the reason they are saying common setup. There is a DC setup. So common setup is common for all the tools. DC setup is only for the DC tool. And then run DC, run placement, run ICC, whatever be there, that is basically now when you have to run it, all these commands you have to run there. Now let's run this particular part. You can also do that thing. So you are, all of you are inside the DC. Am I right? So do the DC underscore shell at this particular place and enter. Let's the DC shell come. Once you will DC shell, just let me know. Yes, sir. Facing any problem? Have you done the VI? You did the same thing now? Okay. Do the run. Escape colon Q. Do the Q and mark. Same colon. Exclamation mark. Enter. Yes, now it will work. So you're supposed to be inside the DC folder first. Okay. All of you are able to see this DC underscore shell. So now here we will do a couple of things. Okay. Few things like just run the file, source the file, and after that we will type certain commands. I can just show you, like, okay, what is there, how it is going to change. So once you will get this DC shell, do start start underscore GUI. I will show you the GUI portion also. Start underscore GUI. Now, once you will do it, press the enter. Start underscore GUI. Escape. It's working. Press one more time. That's all. Now the colon, shift Q. Enter. Oh, one Q. Okay. Same. Q. Escape. First do the escape. One time escape, two time escape. Now colon. Shift colon. Q. Enter. One more time. No. Same. Escape. Colon Q. Enter. Okay. So when I have done this start underscore GUI, now you are seeing some another pop-up, This window is there. How many of you are able to get this pop-up? In your case, now it should work. Oh, it's taking time. Just once again, how many of you are able to get this pop-up? What about you? What happened? Oh, DC shell is taking time. Okay, good. So now let's go back to the DC shell, like another window. Just press the enter so that you will get this DC shell. Okay, now you have this DC shell. Now quickly do one thing. Write a command here, source, SOURC, source space DC underscore, sorry, not the DC. What is the name of the file? Run. Run underscore DC dot tickle and press enter. So on the terminal, you have to write DC shell terminal, you have to write the source space run underscore DC dot tickle, press enter. And let me know what is happening on the terminal and the GUI also. It will let the GUI come. Okay. So current design is full header. Okay. Good. Here this is coming. Just do the CD space DC. Capital DC. Current design is, go to that window, GUI window. Yes. Same. Where is the GUI window? Oh God. You can shift anywhere. If something is working, is good. Why it's like in your case it is happening? Where is your full header, sir? It's here. Oh my God. Do the DC underscore shell enter. No. So that's a command. That's a command. How to invoke the DC. Okay. So when, am I right? So those who got me in the left hand side, there is a something is written. Am I right? What is written there? Full header. Just can you just click that? Nothing is happening, is it? Okay, wait. Right click and schematic view. Right click and the schematic view. सर वो उनको बुलाना चाहिए था सर अभी सत्य गुप्ता सर those the four they're waiting. Start GUI enter. Yeah. So here. No, not. Yes. This was the terminal, na? Enter. Just press enter. Now do the source space run underscore DC dot tickle. Once the GUI, select header, do the right click schematic. On the right hand side, you will get some boxes there. Now double click on that particular blocks. Take a mouse, double click there. Then you will see certain circuit. Just full header, na? Double click here. Yes. Yes. Or not, do not, no need of closing this window, okay? So let it be like this. Come here, enter. Now do the source.
What to, right?
वो भी करेगा.
Let source it there.
सर यहीं करने देता. Enter करो यहाँ पे. Source command is there. Source space run underscore DC dot tickle. Yes, tell me. तो अब डबल क्लिक इस पे राइट क्लिक करो. Schematic view. Come here. Enter. Source. All of you are able to see that design? Yes or no? Yes. Double click on this full header. Guys, yes, no, yes. It's good. She is doing on a two laptop, two system. Where is that guy? Okay. I was like, okay. Great. So let me also do thing. So here I just double click. Now I have this particular circuit. You're able to get this? Yes? Okay, so now I have to show a couple of things here. So now, if you see your system, okay, so there are going to be some cells like this. If you will hover your mouse there, it will tell you like, okay, it is a, I think it's supposed to be AND or inverter, AOI cells. Am I right? Just hover, it will give you a window, something like this here. And here, if you will see here, it is written AO22X1. Okay, that means it is not an inverter, it is a AND OR cell. Am I right? That means now what is happening? You're telling the tool this is a library, this is a design, just map it. What the tool did, tool just mapped it with this AO cell. Am I right? But you are saying I don't need any kind of a AO cell. I want to restrict the tool like, okay, don't use any kind of a AO cell. Then how you are going to tell the tool? Obviously, they're going to a certain command. With that particular command, you will tell the tool like, okay, see, don't use the AO cell, and then give me the code. So just go back to your terminal. Okay. Now I will tell you one command. So basically, that as such, that is already written in our so maybe you're not supposed to open it, but you remember we source just right now run_dc.tcl. So here I just captured couple of options, like here it is written set underscore don't use. So we are setting like, okay, don't use. We are telling the tool like, okay, don't use. Then we were like get lib cell. This is the command. Library cell, get the library cell, and then I'm saying AO */AO star. That means any cell which is starting by the name of AO, don't use that particular part. So I'm just writing the same command. You can also just manually write that thing and just make sure like, okay, don't make any mistake. So it's a set underscore don't use space get lib underscore cell, and then yes, square bracket, yes, you're right, /o star and square bracket. So you have to write this particular command, set underscore don't underscore use space square bracket get underscore lib underscore cells space asterisk sign, which is a star, okay, /AO asterisk and closing the square bracket. Once you do it, press enter. Oh, AO, it's not a zero, it's AO. and press enter. 1. If you are getting a 1, that means yes, successfully everything is, that means your command is correct. Okay. If it will give you the 0, that means either it is not able to find out the any kind of these AO cells, that's the reason it's saying 0, or maybe it will give you some syntax error. But if you are getting a 1, is good. Now you mention this particular part, there are two, like, okay, see, I'm giving you this particular instruction. Now once again compile it. So you have to write COMPILE, compile, and enter. COMPILE, compile and enter. Then again you will see full underscore header. Now go to the design window. Oh, what happened? This crash. Okay. Yours is also crash? Everyone? Nope. Mine is crash. Okay, no problem. क्रैश हुआ होगा तो पीछे का जो विंडो होता है वो बंद हो गया होगा. सबका हो गया? आपके में तो आ गया ना? हाँ, जो नहीं आ गया उस पर स्कीमेटिक पे क्लिक करो. आप क्लिक करो स्कीमेटिक, इस पर डबल क्लिक करो. हाँ, सबका क्रैश हो गया है. चलो. हाँ जी, हाँ जी. इट्स नॉट, आपने ओ कैपिटल ओ नहीं बनाया ना? ऐसे कैसे हो सकता है? तो आपने ब्रैकेट जो है वो क्लोज नहीं किया था ना, स्क्वायर ब्रैकेट. आपने भी ब्रैकेट कहाँ क्लोज किया है? अरे ओके, सो सेल्स के बाद स्पेस देना है. सेल्स स्पेस एस्ट्रिक. कहोगे को तो दोबारा से प्रोसेस स्टार्ट करो, कोई दिक्कत नहीं है. हाँ, इसको वेट करो. वेट आपको तो हो गया ना, आपने दो दो विंडो खोली हुई है. करो वेट, एक पे जाओ, किसी एक को भी खोलो. हाँ, तो इसका एक क्रैश हो गया, एक बचा हुआ है, अभी भी जिंदा है. हाँ, सो जो अभी तक हम लोगों ने अभी तक आप डीसी आ गए थे, तब आप दोबारा से सोर्स कर दो पहले फाइल. सोर्स स्पेस रन अंडरस्कोर dc.tickle, वो आप सोर्स कर दो. उसके बाद आप स्टार्ट हुई कर दो. ठीक है. फिर उसके बाद जो डोंट यूज वाली कमांड थी वो टाइप करना है. उसके बाद फाइल करना है, एंड देन वी हैव टू सी. अब आपका जो कंपाइलेशन मैम का हो गया. कंपाइलेशन मैम, अब आप आपका एओ सेल है. आई थिंक यू विल नॉट फाइंड एनी एओ सेल. ओए है, ठीक है. हमने तो किया था ना उसको. व्हाट एग्जैक्टली वी हैव डन? We have asked the tool don't use any cell starting with AO. So if you want, like, okay, tool should not any cell with OA, just give the same command once again with the OA asterisk. Do the compile. See, this time tool will not have anything with respect to that. Is it working for you? So then restart, na? Restart it, okay? Save it, crash, restart. It's just like that. So if you will remove the DFF, then there is a problem, okay? Because in your design, because in a RTL we are using that pause edge ना. हाँ, pause edge use किया तो DFF तो आएगा. Sequential कैसे? अगर आप DFF मना कर दोगे तो वो हो सकता है SR उठाएगा, SR से D flip flop बनाएगा. It will do something in that way. हाँ, it will automatically do that part. दोस्तों हो गया? Is it done? Are you able to restart the DC shell, start, run source space, run dc.tickle, then type that particular command, okay, compile, then right click, schematic, double click. Now see, do you have any, you have the AO cell, na? This is the AO cell. That means you haven't tried that. AO cell is the AND OR cell. This is the AND and OR. So now you have to type that command. Don't use set, don't use. And after that, compile. Have you done the compile also? Okay, just do the compile. Now go to the terminal. Design. Just once again. Schematic view. Double click. How come the AOI is coming? Just show me. Oh, this is the OA cell, sorry. OR and AND. This is not a AO cell. Now it is coming OR and AND. AO किया था आपने after second time ना? So good na? There is no AO cell, am I right? Is there any AO cell? No. There is a OR and a OR and AND gate. Okay. So what we have done, so basically in this particular way, you can instruct the tool like, okay, don't use these kind of cells. Is it clear, guys? Yes? No? Can you play around with this particular command now? Yes, tell me. Yes, again you have to do it. Same command. In place of there, in the last you have mentioned AO. Now just do the OA. So it will not work in that way. You have to analyze. So basic, don't go in that direction, okay? Because you have to remove, unset that don't use part, okay? So in place of that, what I will recommend you, restart. It will take less time. Okay, so now if you will go to the terminal, the other terminal, okay, where you have the one of the empty terminal now, you just do this cat with respect to the run.tickle. So there I just want to show you one more thing. Let me just show you that. Okay, here. So there is a command. If you will see this, read underscore SDC. So what we have done till now, we have done the analyze, elaborate, compile, but we haven't provided any kind of a constraint to my tool. We haven't mentioned like, okay, you have to do the analysis, you have to do the mapping with respect to these particular timing number. We are just saying like, okay, just do this. So it did it, that's all. But there is nothing like you have to do within this particular time, this is the clock frequency and all other things. So now what we are going to do, we will tell the tool like, okay, see, whatever you have done a good job. Okay, now the next thing is you have to apply the constraint and then you have to compile it once again. Now for that particular constraint part, what you have to do, you have to write this particular command. So let me just write it, okay? So the same terminal dc underscore shell, just do the read underscore sdc space dot dot slash constraint and then full adder dot sdc. You have to write this command. Read underscore sdc space dot dot slash constraint, which is in a capital letter, slash full adder dot sdc. Just write it, press enter. Once you will press enter, after that, again do the compile. Do the compile part. And let me know what you are seeing. So once you will do the compile, again the same window will come. In that again, you have to do the right click, show schematic, and see if you are seeing any difference with respect to the previous one. Oh, is there a lot of difference? Oh, its number of cells has increased, is it? Now we are constrained after that, it increased the number of cells. But if we will do the any kind of analysis, we will come to know it's not about the number of cells they have increased, it's about the timing also. They did certain timing part, optimize the timing. Maybe now they are using the large number of cells, but from the timing point of view, this is a faster one, because initially they were using the AO cell and they figure out like, okay, AO cell is giving me a lot of delay. OS cell is a big cell, is giving me a lot of delay. So what they have done, they in the sense the tool, it figure out from the library like, okay, which other cell I can use in place of this, which can give me the less number of delay, less delay. And that's the reason everything has changed. Compile and enter. Okay, let me also see if I'm getting some other version. Start GUI. The GUI. Okay. So this is the GUI schematic. Double click. Okay. Great. I think everything is gone from here. Am I right? Now, whatever be this gate level netlist, so now you can play around. If you will change the constraint, so right now, I'm not just going to tell you like, okay, how to change the constraint, but there is a file constraint. You remember like whatever we have sourced, you can just go there. Don't play with the commands, okay? Play with the numbers. Especially what you can do, there is a number, the command is a create clock. The create clock command is basically the clock frequency, clock time period we are talking about. You can time period and see what will happen. Change the clock time period, save it, source it, compile it, and see what difference will be there. Okay. Now before we move to the next, there are two more commands. Let me just show you that particular command. One is with respect to, okay, so do one thing here. Till now we were doing the compile. Now just do the compile underscore ultra. Compile underscore ultra. Okay. Enter. And then see if you are seeing any in the schematic. Compile underscore ultra and enter. And then go to the schematic window and see if you are seeing any difference. In my case, the number of gates has decreased. At least in my case, it's happened. Now, what happened? What is the difference in the compile and the compile ultra? Basically, both commands, both are going to do the compile. It is basically from the synopsis point of view, like they are offering you do the compilation, or you can do the advanced compilation. So it is that particular part. So they have the different ways of selling their licenses. Okay, so like compile license is different, compile ultra license is different, because that is the advanced one. Here, see, in the small design you are seeing a significant difference. In a small design itself you are seeing a difference. Now think about the bigger design. Now it is obviously it's going to take comparatively like time just to compile it. Advanced compilation was going to significantly reduce the size of your design. Now what different it is? It is just an algorithm. Okay, it is going to increase the number of iterations and all. It will do that particular part. Okay, so now if this portion is done, now we have to write the Verilog gate level file, because till now we haven't written anything which is like in a gated netlist. You remember I talked about like, okay, there is going to the netlist, I'm going to use that particular word. Now I will say it is a netlist which is a Verilog format only, but it's a gate level netlist. So now let's do that particular part. So maybe you can write it, or let me see if I can just give you the command directly. Write space format. If you can just copy the thing, okay, then the Verilog. Okay, then I can say hierarchy. So if you can write this command is good. Else if you are not able to write this, I can give you a short form of that, okay? Or maybe let me see if it is already there and no need of writing this command. I think you can skip this particular command for now. Can anyone just show me folder? Just go to the terminal. This here. Just do the ls. Oh, so your RTL one. Go to the DC. Come here. Show me the DC CD space dot slash capital DC. Enter. ls space ls space result RESUL tab button. Go down. S, write the S, enter. Where is the other one? Control C, okay. No. So that means you have to do this step. Okay, wait a minute, guys. Then write this command. Okay, write this particular command. Write space minus format space. That means we are just trying to write a Verilog file. We want to keep if there is any kind of a hierarchy as a output. I'm just giving the path of the output, which is a results slash full underscore adder dot map dot v. The reason I'm very specific, very particular with this particular file name and the directory, because the next step which we are going to run as a ICC, it is going to pick particular file from this directory only. Okay, so you have to be very precise. Okay, you have to write as a output space results RUSLTS results slash full underscore adder dot map dot v and press enter. It will tell you like, okay, writing Verilog file, that is done. You got a 1. Yes. Everyone's getting a 1. Yes. Good, guys. After that, press right exit and come out from this DC shell. Write EXIT exit. Now once this is done, then we will see whether you have written the map file correctly or not. For that, what you have to do, just do the cat space results and then full underscore adder dot map dot v and enter. Results, then slash full underscore adder, yes, map dot tickle, map dot v, dot map dot v. What is this? Okay. So when I have done this particular cat part, so let's see what is the file, same input, same module, same input, but this time it having something DFFX1 underscore RVT. These cells are there. Similarly, here in my case, it is showing FADDX1. Now, I would have optimized this particular part. It is a song, don't use cell. I would have used the don't use as a full adder. So there is a full adder present in the library. So what the tool did, it picked that full adder directly as a compile ultra. Initially in the normal compile, it was not picking any full adder, but when we have done this compile ultra, it picked the full adder directly from the library, because in the library there is a full adder. So that's the reason here it is capturing it as a full adder. X1, R1, V1, this particular part, and then DX1, DX2, DX1, these things are there. Okay, so this file is basically coming here. Is it clear, everyone? So this is same file, same RTL, but now it is represented as a part of your gate level netlist. Make sense, guys? Okay. So now what you have to do, DC, you are in the DC folder, come out from the DC folder as a CD space dot dot. You are in a PWD. If you are able to see all these files, is good folder. After that, go to the ICC2 and enter. To see this report result script work underscore dir. Can we take a quick break of 5 minutes? Not more than 5 minutes, okay? Yeah, please. It's 4:21. Just come back 4:25. 4:30. You have to move from there, okay? Okay, guys. So let's start the ICC part. Okay, quickly. So now we are inside the ICC folder. So same CD space ICC2, enter there. Now there, if you will do the ls, there are the 4 directories. So what I'm doing, just to show you, like, okay, what is present inside these directories. So report is empty, result is empty, work directory is empty. There are certain scripts as a part of the script folder. Now here, if you will see, there is a one script as a floor plan.tcl. So the way we have this run dc.tcl, similarly we have the floor plan.tcl. After the floor plan, we have the power plan. So we have the power plan.tcl. Then after that, we have the placement.tcl, clock.tcl, and the route.tcl. So there are the 5 scripts I have there. So what we will do, we will take one script, run that particular script. In place of going command by command, I will just show you right now what is there, and we will just source that particular file. Okay, what are the changes we have to do? Well, like, what are not the changes, what are the things, I will just explain you that particular part when I'm going to run it. So you're not supposed to open the file, but let me just explain you that particular part. Okay, so what I'm going to do, when you are inside the ICC2, same ICC2 underscore shell and enter. This is something all of you have to do it. Just do ICC2 underscore shell, let the ICC2 shell come. Okay, the way the DC shell was coming, similarly ICC2 shell will also come. In the meantime, let me explain you what we are going to do as a part of a first script file, which is our floor plan file. Okay, now in the floor plan, what exactly we have done. So first thing is, at any stage after the DC, you have to tell the tool, like, okay, see, this is my reference folder. Okay, because see, now there are 2 ways what you can do. You can tell the tool, like, okay, see, you map date everything, now you save this, whatever the database, now you saved it in a one place. So tool can save that particular part. Now maybe in our case, the .lib file, .db file is a small file, but in industry, single .lib and the single .b file is around like 1 GB file, 2 GB file. That means it has a lot of content, and we are not talking about the 1 or the 2 file. There are almost like 30, 40, 50 files. Now if we will talk about the 2 GB average with the 40, that means 80 GB files you are talking about, and you're telling the tool, like, okay, see, load everything. That's not a wise solution. So what we will do, what we are telling the tool, like, okay, see, don't worry, we are going to provide you that reference where all the .libs are present. Okay, all the .dbs are present. You just keep a mapping inside your database with respect to that. So you will see, whenever you will change the path, reference path, always there is a problem. It will say, okay, I'm not able to find this particular library file because in my database that library file is present. So here also we are going to do the same thing. So that means every time you have to provide this particular reference at each and every path. That is the first one. PDK path. Then the PDK path, now I was talking about the database. Okay, so what happened in the database? So if you will see this PDK path, there is a lib, there is a NDM, then we are talking about the NDM. This NDM is new data model. You remember in the morning I mentioned ICC and ICC2. So this is the difference in the ICC and ICC2. In ICC, first version of ICC, all of you guys can see what is inside the database. Now what they have done, they created a single file as a .ndm file, and you cannot just go and see what is inside the database. In a layman language, you can understand, in the database, let us suppose there are the 10 different files. What they are going to do, they will zip, convert into the binary, and they will create a one NDM file. And then in that NDM file, what library I'm talking about, it is creating a full underscore adder underscore library. This is something you can give here as a name. So in your case, maybe you can write your name also. In my case, just for the understanding purpose, I said full underscore adder underscore lib. This library I have created inside that particular database. Okay, so there going to be one reference database, very small database, which is a standard cell database. Okay, in that standard cell database, I'm adding a one more library. That is the meaning of this particular create library. Once you have created this library, your PDK is there, library is there. Now what is the next one? You have to give the design. So this is the design. And if you remember, I told you like a design which we are going to give is supposed to be the mapped RTL. So same thing, DC results full adder dot map dot v. This is what we have just write out from the DC. Am I right? So that file, and then what is the library? We want to add this in this particular library. So library full adder dot lib, which design? That design is basically full adder design. So in your module, library module, there is a full underscore adder. So that name to be here because that is the design name, module name, design name. Which library you are reading this Verilog? This library which you have created here. Now in this particular way, basically you are referring to the database, the library which you have created this by the naming of this, the design which is present in your RTL. That portion is done. Once this portion is done, it's just like floor plan, what all different things you are going to do it. So let me just show you like, okay, what we are going to do it. Initialize floor plan. You will say, okay, do the start floor planning activity. Set individual pin constraint. If you remember, I told you side, you can specify the coordinates. I specified the side. In a side 3, you have to take all the ports. Then I was telling you like, okay, create placement. Now create whatever the diagram you want to create, just create that particular diagram here. So I said create placement floor plan, placement of a floor plan. You just create that particular part, save the block and the save the library and done. No need to do anything else. Clear? That's the only thing. Now there are the couple of scenarios. This is the scenario 1, the scenario 2. So in the scenario 2, same initialize floor plan, same. But this time I'm giving a direction. I'm giving a direction to the tool like, okay, see, you have to use certain core utilization I mentioned, certain offset, like, okay, you cannot just place the cell here. You have to just go inside this. Some in terms of the pin constraint, I'm talking about the side 2. I'm telling, okay, the difference spacing distance between the two pins supposed to be this much. And then we are saying same, create placement hyphen floor plan. So there are a couple of options, the scenario 1, scenario 2, scenario 3 I have mentioned in the script. Maybe later on you can just go back and just see the different options. So scenario 3 is there. In this particular scenario 3, same initialized floor plan, but this time we are saying, okay, we don't need a square or the rectangle, we need a L shape. So this is the L shape is there. And what is the coordinate? What is the length and all? That is there. Then we are telling, okay, this is the constraint. You have to apply this particular constraint for the pin. Then same, create placement floor plan. We are just telling, okay, this particular part. And the last we are saying, okay, save block, save lib. Is it clear? So as such, if you will see, there are only 3 commands. Initialize floor plan, then the pin constraint, and then there is a something as a create placement at the floor plan stage. And whatever be the block and the library which we have created, we are saying save block. So we are doing that particular part. So now I'm going to do one thing. I will just run this right now. Here be classroom. So same source. This file is present in the script. We are talking about the floor plan. All of you guys should source it. Enter. Source space script slash floor plan dot tickle. It's done in my case. After that, I will do the start. Okay. This is the command. Source space scripts floor plan dot tickle. That is present in the directory, na same. Just source it quickly. If you have done it, do the start GUI, START, start GUI. Enter. And let's wait for GUI to come. Oh, it is coming as a L shape in my case, okay? Now you can see whatever be our third scenario, because we were like first scenario, second scenario, third scenario, it is the third, it's picking the third scenario because we haven't commented that. And start underscore GUI, same. No, so from where you have started. No, so in your case, it is giving an error. I think you haven't saved this full header dot map. Have you done it? Show me the, no, don't exit. Go to the other terminal here or here maybe. Just do the PWD. Go inside the RTL folder. CD space RTL, capital R, enter, tab button. Then just go inside the DC. I'm coming. Wait. Enter. Go inside the results. CD space results. Tab. Enter. See, it's not there. That means when you have done the DC, last command which I have asked you, you haven't done that particular part. Just do one thing. Just CD space dot. Enter. LS. So result reports, yes, that was missing in your case. Okay, so you have to run DC once again. Okay, and you have to write that particular command which is already part of DC dot. Just open this, run DC dot tickle. Open this, just do the, I will tell you like, okay, which command. Just do the PWD. You are in the wrong directory. That means, yeah, you are in the RTL-to-GDS. You are supposed to be in ICC2. Just exit from here. EXIT. Enter. And now do the CD space ICC2. Then enter. No. So what is happening in your case? You are in the wrong directory. Is it? Yeah. No. Okay. You're come here. Come here. Just source space script SCRI tab button. Now FL and tab button. Now source it. Enter. Okay. Now it will be okay. Is it working for you? License issue. Okay. Wait for some time. It is going to take time. It's working for you. Since taking time, right? What is the status here? Are you getting the L shape? Why you are not getting any problem any point of a time? Those people are getting problem every time. Obviously that's very important. Hey, come on. It's not about the IIT or the SIT or okay. It's about the okay. If they are a good guy, then they will learn everything.
Want to do double click or
No need of that right now. Floor plan is done. Oh, ICC2, it's still taking time. Same here. You shifted from there to here, na? That's the reason. See, the problem with around this girl, okay? She was, तो वही तो बोला नहीं हो रहा था और वहां सबका आप पॉल्यूट करके आ गए हो वहां पे किसी का भी नहीं हो रहा है और यहाँ पे भी नहीं हो रहा है हाँ everywhere in the sense no You cannot use it. Means you can do it, but you should not do it. As such, is a gated netlist, na. So gated netlist is IEEE standard. You can use that. हाँ, वो आप कर सकते हो. Until unless there is nothing related to the DB part, I think you can do that thing. Okay. Anyways, so those then get the ICC one. It's okay. You will get in some time. Let me just go to the next one. So now floor plan is there. There is no problem with the floor plan. So now in the meantime, rest of the people. Okay, let me do something. Okay, so I'm just closing this file. I'm going to show you the other file, which is a power one, power planning. So remember, don't close, don't quit ICC2. Okay, don't do that particular part, because if you will do it, then you have to rerun this part. Okay, so now I'm just showing you the other file, which is a power. Now what is in the power? You remember in the power we have discussed, like, okay, you have to create a power rail, PWD, that VDD and VSS. So if you will see this particular file, we are doing that particular part. So we are telling the tool, like, okay, see, the name of my VDD is VDD, name of my ground is VSS, this is the ground, this is the PG net, power ground net. Automatically you just create. I'm not giving you the instruction right now, but you have to create, connect, sorry, not the create, you have to connect. You have to connect that thing automatically. Then now what happened, like if you remember someone here, he was telling, like, okay, as we go the next stage, the power is on a higher metal, metal 6, metal 7 and metal 8. We talked about little bit about the stack, like, okay, we will just do the in that particular way. Now you can visualize this thing in a real world also. All the power lines are at the top. Okay, high voltage is at the top. Same thing is here. You can just remember high voltage lines in the design in a power side supposed to be in the top rail, so that there should not be any interference when we are working, like when we are talking, when we are just going here and there. That means whenever there is a signal, it is traveling. It is not like, okay, power, there is a capacitance between them and there is some spark is going to create any problem with the signal. That's the reason we have this power rails at the top in the real world. Same thing we are doing here. So here we are using a metal stack, like that means the metal 7 and the metal 8. Now there are certain rules. That rules are here, like, okay, it's supposed to be in this particular pattern. Which layer? Metal 7. Now you can just go with the horizontal and the vertical as a mesh. So which one is the horizontal? Which one is a vertical? What should be the metal width? Okay, what should be the spacing between that? We are just controlling each and everything as per our requirement. It's not like it's a standard one. It's not a standard one. It's as per our requirement. So create PG ring. We have created. Then we are telling the tool, like, okay, I've created a certain strategy here. You just do the compile PG. That's all. These are the 3 commands. There are the different scenarios. Here also we have kept couple of scenarios, like, okay, with the different numbers. Like here we are using a metal 6, metal 7, metal 8. Previous one we were just using the metal 7 and metal 8. Then create a strategy. It's just a command, like, okay, this is my strategy, I just want to place in this particular way, and then you will just say compile. So that is what we have done till now, compile PG. So what I'm going to do, when this is done, save block, save lib. So same file I'm going to run on my ICC shell once again. So those who got that floor plan is done, what you can do, just again do the source scripts, and this time is a floor plan. No, not the floor plan, sorry, power plan. And run it. Once you will run it, go to the window here, and maybe you will see something, these kind of meshing. Okay, Are you able to see this? Run that command, okay? Source space script slash power planning dot tickle, okay? And then come back to the GUI, just see what is happening, what change is there in the GUI. And if you will just expand that, if I can just show you that thing, then you can see in this way. See here. So there is a arrow, then there is a plus sign, which is like in a zoom. Click here, make a pointer here, make a square, drag it, okay? Press the mouse and just drag it. It will create a square. That area is going to zoom. Then you will see it is written somewhere as a VSS and the VDD. So what you have done, you created a power structure there. Good. Are you able to do it? So what we have to do, we have to just source the file. The way you have sourced the file last time, similarly you have to source the file this time also. In the ICC terminal, do the source space scripts slash power. Press the tab button, it will come power planning dot tickle, I think. Just press yes. Power planning. Just enter. Oh, what is it saying? Could not open the script. Just do the P, maybe in the wrong direction. Enter. You're in ICC 2. Okay, then power planning dot tickle is not present. You're saying we could not open. Can you just do the ls? Okay, do the ls space scripts and tab. Again, you press the tab button. Tab button, ma'am. Here, this is the tab. Okay, enter. So you have power underscore planning, ma'am. Power underscore planning dot tickle. Is it clear? हाँ हो तो गया सब. अभी तो प्लेसमेंट आया नहीं सर, अभी आएगा. प्लेसमेंट कहाँ है? अभी तो हमने फ्लोर प्लान साइट रोज. ओके ग्रेट, आई विल जस्ट शो यू. हुआ आसपास किसी का? किसी का भी नहीं हुआ यहाँ पे? ये यार कैसे? इट्स टेकिंग टाइम. हाँ आपका क्या हुआ सर? आपने तो चलाया नहीं. ओ हो गया, देखो उसका हो गया. हमारी प्रेजेंस जरूरी है. ओके जस्ट गो आउट. फर्स्ट टाइप cd स्पेस डॉट डॉट. हाँ आपके आने से नहीं हुआ ना, हमारे आने से हो गया. आपका हुआ? नहीं डोंट डू दैट, वो उसका ट्रिगरिंग है. अब आप उस पे जाओ, वहां पे जाके जो टर्मिनल है, दूसरा टर्मिनल जहां से आपने सोर्स किया था, हाँ इस टर्मिनल पे जाओ. यस, नाउ सोर्स दी फर्स्ट फाइल which is a floor plan. Source space scripts slash floor plan scripts s tab. Okay, yes sir, do the pwd sir, pwd. So you are in the wrong direction. यहाँ से बाहर हो गए. स्पेस स्क्रिप्ट आपको आईसीसी 2 में होना है. आपको हो गया? हाँ गुड गुड वेरी गुड. हाँ जी मैम. गुई तो पहले खोला था, बंद कर दिया था आपने गुई? अच्छा आपका भी हुआ है. ओह ग्रेट, ठीक है आ जाएगा आ जाएगा. क्या हुआ? आएगा आएगा. व्हाट इज नॉट फाउंड यार? जस्ट डू द so you are inside the script folder. You have to come out. Okay wait just do the pwd. Now you are inside the wrong folder. Okay, do the pwd, enter. Okay, you are in the RTL to GDS, not in ICC2. Do the CD space ICC2, capital ICC2, capital I and tab. Press the tab button. ICC, press the tab button. Enter. Now source that file. Okay, great. So people are able to see something other thing. Now we have to do the quickly the placement part. So let me show you the placement part also. Okay. So now if you will see this script, which is a placement script. Now let me tell you like, okay, what is there inside the placement script. But before that, I just want to tell you two important things. So when we were talking about the libraries, so what is the content of the libraries? .lib file. What is the content of the library? The content of the library is they have the timing number. They have the power number. Yes or no? Say yes or no. See, I'm supposed to be more tired than you, okay? So at least you can say yes or no. Okay, great. So now if anyone is going to ask you like, okay, how the people was like, okay, what power number? What calculation they have done? They have calculated the delay. Now, delay in the sense, if there is a wire, it has a resistance. So signal will take time to reach from one place to another. Am I right? Yes. Now, that means it has a dependency over the resistance. Yes or no? Good. Now, do you remember like in the 11th and the 12th, when we were calculating 11th and 12th standard, when we were calculating the resistance has a dependency over temperature coefficient we were talking about. That means if I will change the temperature, the resistance is going to change. Yes. So if I give you a laptop or a mobile phone, and if I will give you a specification that okay, this laptop or the mobile phone is going to work only when the environment temperature is 25 degrees Celsius. Do you think it's going to work? No, because at least in India the temperature fluctuation is very high, 0 to 50 minimum. If I will say okay, the range is 25 to 35, no. So you need something which will work in the minus also, like in a Noida, the temperature goes till -4, so it should work there also, and it should work in a stage where it's the charging and the full blown 50 degrees Celsius. Now, if I will ask like, okay, now when I'm going to calculate the resistance and going to do the simulation within this particular range, then it's going to create a problem, because you cannot just come up a single file with this much of range. So what people do, they prepare the different files with respect to the different temperature. Make sense? Different files with respect to the different temperature. Now till now we were not talking about the different files with respect to the temperature. We were talking about the files, just file. Now if I will say okay, see, I want to make sure okay whether my design is working at 25 degrees Celsius, then you say okay Puneet, let's do one thing, let's give this particular file and do the analysis. Whether my design is going to work in a 40 degrees Celsius, give this file and see. Whether my file is going to work in 0 degrees Celsius, you will say okay, give this file and check this part. So I cannot do every time this kind of iteration. So then the concept of the scenario come into the picture. So here you will see we are talking about something function, mode, something known as a corner. So these corners are basically with respect to those temperature. So not only the temperature, there are the other variations also, which is like you can just note down, maybe you can read later on. There is something known as the PVT variation, process voltage temperature. That means the delay, power, it has a dependency over the process. Now which process? The foundry process. So foundry is also not going to tell you like okay what is the variation we are talking about. They will say there can be an impurity, there can be a variation. So that is known as the process variation. Voltage, In a wire, if the current will flow, temperature will drop. That means the voltage, maybe the one inverter on a 5 volt, another in the 4.8 volt. There is a variation. Similarly, temperature I just discussed with you. So that means there are a different combination of process voltage temperature, and those combinations are known as the corners, PVT corners. So here what we are going to do, we will tell the tool like, okay, see, I want to do the analysis on this particular corner. So till now we were just doing the mapping, floor planning and everything. But now we are talking about then the real sense, placing the cells, doing the analysis, the timing and all other things. So we have to tell the tool like, okay, do the analysis with respect to this particular process. So that portion is come as a part of this. Create mode, create corner, scenarios. We have created this particular part. As we provided a constraint file in our DC stage, again we are going to provide the constraint file here, which is like timing part, because now the tool is going to place the cells as per the constraint provided by you. Then similar kind of don't use cell. Once again you have the control. You can say, you can tell the tool like, okay, see, synthesis whatever you have done, but now I want you not to place these kind of a cell in my design. So again you are telling the tool like, okay, see, please don't use these kind of a cell. So it mapped at the synthesis stage. Again you are telling the tool like, okay, whatever you have done, let's, if you can do redo, then do this particular part. So this time in the file I have already captured couple of don't use cell. After that, same, we are just doing certain things like, okay, current scenarios and all. Okay, so that is with respect to the cell. We are talking about the cell. PVT corners comes as a part of a cell. Now when we are talking about the wire, because now you are going to do the wiring also. After this you are going to do the wiring. So in that particular wiring, metal 1, metal 2, we have discussed, remember? That metal 1, metal 2, we also discussed like, okay, there is something like a minimum spacing, minimum weight, remember? Now if I will say there is a wire you are trying to draw with a 2 nanometer, and foundry is saying, okay, see, my mechanical machine, they can draw the 2 nanometer, but there is a precision. It can go till decimal point 2. That means 2.00 is good. It can draw the structure with that much of precision, 2.002 nanometer. But after that, I'm not taking any guarantee. That means it can be 2.001 or 2.09 also. So that means we are talking about the precision. Precision, I think all of you remember, we studied in the, I think 7th, 8th, that scaling precision part. Okay, so that's basically comes as a part of a variation, foundry variation. Now if your dimensions are going to change, C equals to epsilon A by D, overlapping area, your capacitance is going to change. Resistance R equals to rho L by A, length, width, everything is going to change. Your resistance is going to change. So what will happen if your resistance, capacitance is going to change? Your delay is going to change, your delay is going to change, everything is going to change. So for that also, foundry is telling like, okay, see, the variation can be 10% plus side and the minus side. That's what the precision things come into the picture. So for that, there is something known as the parasitic corners. So the way we have the PVT corners, similarly we have the parasitic P1, P2. And if you remember, I showed you one TLU plus file. So this is that TLU plus file. And here it is written the Cmax. Here it is written in the another place as a Cmin. Now what is the Cmax, Cmin? The data was coming from the foundry. So foundry is telling, okay, what I can help you, in which variation the capacitance is going to be the minimum, in which dimensions like variation capacitance is going to be the maximum. So in that particular file where it was written as a W min as a 2, maybe in the C min, W min is going to be less than 2 or the greater than 2, depending upon what kind of capacitance is going to generate. So now you have to tell the tool like, okay, see, this is the technology data provided by the foundry. Now, whenever you are going to do any kind of a analysis, you consider this part also. So that technology data which foundry has provided, based on that, this TLU plus file has a certain numbers. So what this tool is going to do, it will read those PVT files. That means all these cells in a different environment. It will read these wire related information. It, based on the scenarios which you have created, it will combine those now PVT and the RC both, and then it will do the simulation. It will do the timing analysis. It will check, okay, what is going to be the delay, because one side R and the C, they can figure out from this particular file. From the other side, it can figure out the delay number from the .lib file with respect to the different PVT, and then it will do the optimization. So this portion is there. And then if there is any layer change, we are talking about the layer map file. So this is the layer map file is here. We are talking about, okay, you have to read this parasitic file. This is the layer file, and then place the pin. Now till now we just mentioned like, okay, you have to pin supposed to be in this direction. Now you have to tell place the pin and do the placement optimization. Then there are the commands as a legalized placement, legalized course placement. When you are going to do the placement optimization, legalized placement, now book the sites and everything, save block, save library, it will done. Make sense? Now before that, someone asked me one question in a tool, how we will see the site rows. We discussed the site rows and all. So this was our ICC2. In ICC2, if you will see this side, this portion, right hand side. So there is the objects, then the layers. If you will click on the layer, you will see the all kind of layer M1, M2, M3. You can select any layer. Okay, you can deselect any layer. So that means whatever is here, which layer you want to see, which layer you don't want to see, you can control from there. Similarly here also, this is the object. Now in this object, specifically the site rows. So there are two options here. It's written here site array and the site row. So what you can do, if you want to try, you can just select site row and the site array both, like it's coming as a blue. There is the option here apply. Just apply that particular part, and then see in your design. Once you are going to apply, you have to press. Wait, what happened? Okay. So so basically it's there, but yes. So basically what happened? In the site row, you have to expand that. Then there is a cell site. You have to just click that also. Apply. When you are going to expand, you will see something like this. So all this orange color is represent the site rows and the arrays. Okay. Similarly, you can just play around this particular part. You can select, unselect, maybe the route, maybe the pin, cells. You can select, unselect, and you can apply. Then you will see some changes on the layout side. Yes, guys, are you able to follow? I know all of you guys are tired, but I assume like not equal to me. Okay, you're just listening, I'm just talking. Okay, so now let's go back and go back in the sense in ICC2 shell. And now, since we have done the placement, floor plan, floor plan, power plan, now let's do the placement part also. So how you're going to do it? Source, space, scripts, placement.tcl and enter. Oh God, it's taking a lot of time. Let me unselect this. So, what is the difference in the previous and the now? In your design, maybe you will not see difference right now because there are a couple of full headers are here, okay? But in a bigger design, you will see it. Here also you can see now all the cells are supposed to be within that side row. That particular arena is supposed to be mapped with that particular part. So if you will see this D flip-flop, it is in within this particular boundary. All the blue part is there where the VDD, VSS rails are there. You will be able to see that particular part. Yes or no? No? Oh, so yours is not working? Okay, yours is working, is it? So then run this particular placement. You did it? Okay, legalized placement is also done. Great. Great, ma'am. So now maybe you can just remove it and unselect it and just check it. Sir, sir, path is not found. Oh, okay. Your case that is not there. क्या काम नहीं कर रहा सर? PWD करो. You are in the wrong directory ना. Go to the ICC2. So source करो. मैंने आपको 3-4 फाइल्स दी थी ना. कौन-कौन सी सोर्स करी है अभी तक? Okay, so do the source space scripts slash first source the placement. हाँ, CD space ICC प्लेसमेंट नहीं, पहले प्लेसमेंट नहीं आएगा, पहले फ्लोर प्लान आएगा, फिर पावर आएगा, फिर प्लेसमेंट आएगा. आपका हो गया सर? आपका? हाँ, एक्सटेंडेड एरर PWD करो. आप रॉन्ग डायरेक्टरी में तो नहीं हो, फिर आपके साथ क्या प्रॉब्लम है? व्हाट इज द प्रॉब्लम? करंट ब्लॉक इज नॉट डिफाइंड. आपने बीच में बंद करके दोबारा से किया होगा. अब प्लेसमेंट की जगह यार पहले वो चलाओ, फ्लोर प्लान. उधर हो पा रहा है? हाँ जी, आता हूँ. हाँ, पहले फ्लोर प्लान चलाओ, फिर पावर प्लान चलाना. आपका हो रहा है? अरे यार, ऐसा थोड़ी होता है. बताइए. F दबाओ, F. ओके, नाउ डू द जूम, है ना? जो भी आपको देखना, आप देखो, दिख जाएगा. हाँ, अब आ गया ना, सब आ तो रहा है, आ तो रहे हैं सब सेल्स. थिंग्स देयर. हो गया आपका? यस, वर्किंग देयर, वर्किंग. ओके, सो प्लेसमेंट भी हो गया है. CTS राउटिंग कर दें क्विकली. सो इन द इंटरेस्ट ऑफ टाइम एक काम करते हैं, पहले क्लॉक CTS की फाइल सोर्स कर लेते हैं, उसके बाद मैं बताता हूं कि CTS में क्या है. सेम script source clock.tickle. You can just source this particular part. So in case of a CTS, we don't have too much of command, okay? We have to tell the tool, like in my case, it is like some check the design, it will just do certain pre-check, okay? And then it will synthesize the clock tree. Then there are certain variables like, okay, there is a local skew, global skew and all. Now, if you remember when we were talking about the clock, I mentioned very clearly, the clock edge should reach each and every flip-flop at the same time. Remember? Now there may be a possibility, there can be a difference. They can reach in a different time. But it should not be like, okay, one edge is reaching at one flip-flop at 2 nanosecond, other is reaching at a 10 nanosecond. So this difference, when we were talking about this particular difference, we measured this difference with the help of a parameter, and that is known as a skew, SKEW, skew. So it is basically the difference between the clock edges which is reaching at a destination. Whatever the time it is going to take, that difference is basically is a clock skew. You can just note down later on, you can just do the Google and figure out what is this clock skew part. Okay, so our primary goal is to make sure this clock skew supposed to be 0, but the industry people, they said it is not possible. So then we were like, okay, if it is not possible, then give us a number. Then only I will tell the tool, like, okay, see, within this particular range, there is no problem. So this variable, when we are talking about C2S optimize enable local skew, okay, here the global thing, backend of that, which we haven't captured in this particular file, there are the certain numbers which you have to mention, like, okay, this is supposed to be the clock skew number. So we are not going in that particular detail, like, okay, where we supposed to set, but we are saying, like, okay, somewhere we have set it. If you will just check that particular part, it will take care of this, and then just build the clock. Done. So this is what we build the clock. Now in our design, because it is a adder, there is on an input side there is a 9 flip flop, output side there is a 5 flip flop. So there is a not much difference. We are not going to define a lot of other parameters of the clock. It's a very simple one. It's just like if you will go to the tool side, okay, so I just run that particular, you remember I run the clock script. So if you will run the clock script, you will see these type of connections. Are you able to see it? So before this, it was only the power. It's basically the floor plan, power plan. So power rails were there. Then we did the legalized placement. You were able to see the site rows. You were able to place all the cells there. Then the next one was the routing of the clock. So this is the connections I was talking about, the routing of the clock. And if you will see, I think it's giving some error. That's the reason. No, everything is good. Wait a minute. Yeah, so no error. Basically, it is basically power rails are bigger. That's the reason you are not able to see it. But if I will show you here, okay, where is the clock? This is M2. Okay, so if we will zoom here, let me do one thing from this side now. Let me just remove this power side first. So PG region and net type. Let me just remove this power in the ground. Let me apply here. Okay, now if I will just show you this part, and if I will just hover our mouse here, then you can see here it is showing you the clock. So this area. So what I have done, I just from the display point of view, the power part. So here there is something as a net type. So we have the net type as a power in the ground. I disabled that. So now you will not be able to see that line here. It doesn't mean it's not here, you are not able to see it. You just disable that particular part. Now if you will just zoom and if you will see this particular wire, which is you are not able to see here properly, but it is in my screen. This is a I think which color? Pink color. Okay. So if you will just go there, it will show you somewhere here like, okay, this is a clock net. This one. So here it is written as a clock and the layer is a metal 2. So clock is on a metal 2. So that we have done is the clock routing. So in this particular way, if you will just scroll up and the down, you can see all the clock here and the respective pin. So this is a D flip-flop. In the D flip-flop, we need the clock that is here. Yes? How many of you get this? 1, 2, 3, there, done. 4, 5. Okay, great. So now let me show you the last script, which is a placement routing part. Okay. And in the meantime, let me just run the route also. And let me just show you the, wait, what is this? Okay, wait a minute. It is in a line number 17. Okay. Okay, let me disable this. Oh, so what you have to do, I think, just open the file, line number 17, there is an error. Maybe you can just comment that particular part for the time being. Now it will run. Okay, let me just show you what is there inside this particular file. Okay. So guys, you remember like we were talking in the route as a tracks. Remember that particular part? Yes or no? Route tracks, remember? Little loud, okay? Great. So now when someone is going to do their routing, so first you are telling the tool like, okay, there's supposed to be the tracks. Now the thing is like, okay, if you will tell the tool like, okay, there are the 10,000 wires you have to design, they cannot just design just like that. So again, there are the 3 stages for the routing part. First one is a track assignment. Okay. Global routing, track routing, and detailed routing. Now, what is the global routing and the track routing? First is a global routing. Global routing in the there the wire. Now saying this is a cell, this is a cell. Now, how you want to connect this? So what will happen? Like, okay, globally, I will say like, okay, see, whenever you travel, you just go to the Google map and just see like, okay, how many cars are there, where the traffic is there, whether the traffic is the red or the blue, and accordingly you choose the path. Am I right? The same thing happen here. What it will do, it tool know very well, okay, in this particular area, metal one, how many tracks are there? That we have discussed, like, okay, how it is going to calculate. So what will happen? The tool is going to do the analysis. If I will route this wire from this particular place, is it going to be red? Is going to be green? Is going to be yellow? Same color mapping. If it is a green, it will route. So it will assign like, okay, I will route this wire from this particular place. That is the first stage. If it is a red, it will search for another place. Okay, I will not route from here, I will route from here. So that means there is a something known as a color map. It will do the color mapping. It will tell you like, okay, I'm not able to route from this particular area because there's a lot of traffic there. So that comes as a part of a global route. Now once the global route is there, now you have choose the path, like, okay, this is the path. Then in that particular path, there are different lanes. Now you will say, like, okay, if you will stick to this particular lane, there is no problem. Everything is clean. So basically, it's more organized, not like in India, like, okay, people are just shifting the lanes like this. It's like in the US. Look, okay, if you are in this particular lane, you have to be in this particular lane. That's all. That is the something known as a track assignment. They will assign the track to you. Like, okay, once you are on this particular highway, you have to stick on this particular
track on this particular lane. That is the second stage. Once this is done, then they will say, okay, go. Because now I have done all the analysis. You are going to choose this path. You're going to choose this track. Now you have to go. That is basically the detailed routing. So 3 stages. Global route. First, choose which highway. Second, track assignment. In that particular highway, which track you are talking about. And then when these 2 things are done, then you will say, okay, go. Same thing is in the script. First thing is the global. Forget about the command. Okay, we are talking about something with respect to the global. First, we will do the global part. Second thing is the track part. So this command is basically do the track part. Third one is the detailed routing. Here you will see there is a detailed routing commands related to these commands. Okay, so that means these 3 stages are there. Once these 3 stages are there, is done, then first you have done all those application variable, and then you are doing route global, route track, and route detail, and done. Am I right? There we define set app options. We define the options like, okay, these are the options on this particular base. I will choose the highway. I will choose the track in this particular way on this particular metal layers. I will do the detailed routing, and then you are just running these particular 3 commands. And once you will done, everything is done. Now you are going to write the Verilog, whatever your final constraint, whatever your parasitic, you can just write that particular part. This is done. So basically this is going to be your routed netlist. So we can write the netlist after each and every stage, but the point is, like, after this your design work is done. It's like this routed netlist, you can take it to the next level as a verification engineer or something, and you can do rest of the portion. So I just did that particular part. I run the command. If you are able to do it, it's good. If not, maybe you can just sit back and you can do later on. Okay. So now you can see here. So now you can see all these wires are here. If I will just click it here, so you can see this is a signal wire and proper. This is basically not just a single line. It is a, all the wires are there. Can you just try? Just run it. We're almost done. This is the last time you're going to type any command and press enter. So timing, maybe we will skip, okay, that PT part, because PT is like it's an analysis part. So it's already 5:30. If you want to stay another 1 hour, I'm okay. I can just do that thing, or at least half an hour. Okay, it depends on you. So he said no. So, but yes, till routing, everything is done. Now after that, if you will run this script, you will have the routed.p file. You can open that file. You can just see, okay, what is the difference in a first RTL, gate level RTL, and the routed RTL. You can see that particular part. Okay, so in your case, it is a comment. Okay, how you're going to comment that line? Okay, so maybe you can open the VI that file, then go to that particular line number, press I. Yes. Still you are facing the same problem, is it? No, no, no. So for this, you have to go to the line number 17 and this. So go to the different terminal, routing. You have to source that particular routing file, but you have to do first one line number 17. You have to make certain changes. You have to uncomment. You have to comment that line. You have to remove that line. Maybe
So do you have any idea about the Unix part? That is the problem. So maybe I can tell you. Yours is working? It's giving an error now. So go to the terminal, other terminal. Just come out from DC. VI space, okay. Do the ICC2 capital, tab, press the tab button. Scripts, SC, that routing, IC2 two scripts, then the routing. Press tab, just route R, O, and press tab, enter. Okay. Now do the colon, press shift colon.
Routing.tcl or
Routing.tcl, sir. Yeah, this now. Now source that file there. Sir, close करें? I'm coming. Just 1 second, okay? So online guys, thank you. सर एक फोटो है सबको बुलाया था we call the other guy